Et bonjour à tous, bienvenue sur Decrypted. Encore une nouvelle interview aujourd'hui. Je suis avec Joe aux questions et cette fois, on a le plaisir d'interviewer Ratan de Succinct. On va expliquer ce qu'est Succinct dans la suite de l'interview. Comme d'habitude, cette interview elle sera traduite en anglais directement. Vous pourrez retrouver en description la version originale directement en anglais si jamais ça vous intéresse. Hi Ratan, how are you doing today?
Doing good, doing good. How about you?
Very good too. I'm very
Very
happy
good.
to have you on stage with us today. Lots of things to discuss. So just to briefly begin, who are you, Ratan? Well, give us a little presentation and maybe introduce us what is Succinct and what Succinct do in crypto landscape.
Yeah, definitely. So, yeah, my name is Ratan. I'm a founding engineer at Succinct. At Succinct, we've been building SP1, which is a ZkEVM, a zero-knowledge virtual machine that lets you prove any Rust program or any language that can be compiled to RISC-V inside of ZK. So let's say you want to prove an Ethereum block. You can run a Rust Ethereum execution client inside of SP1 and prove it without having to write custom circuits. So this is something that we launched in February of this year, and we've seen an insane amount of growth since then. You know, teams like Celestia deploying Blobstream, Avail deploying Vector, and Polygon using it to secure the AG layer. So SP1 is being broadly adopted. I think ZK is becoming way easier for people to write. Yeah, just a lot of cool things happening to think of the past couple months. Yeah.
Pretty
Okay.
clear. We will talk about all of these topics during the interview. Basically, just to start, what is Succinct North Star? Or what is the main goal and what are you targeting the main goal in Succinct?
Yeah, I think it's a great question. It's something that we think about a lot. I think that for us, what's really important is like, what is the purpose of, ZK and zero knowledge cryptography? I think for a long time, it's been incredibly focused on specific applications within crypto. So, I mean, one of the things that we're really excited about is how ZK is really powerful for scalability. It's something that's been talked about a lot, but it's been somewhat difficult to implement, right? You've had teams that have been running custom circuits to create ZK rollups, right? Essentially, teams that are building layer twos want to have solutions to essentially roll up these transactions to the layer one in a secure way. ZK provides a way for them to do that, but it's been quite hard in the past for these teams to do so. So with ZkEVMs like SP1, it becomes incredibly easy and also performant to prove the validity of those rollups. So I think that's something we're initially excited about. But long term, I think the power of ZK goes beyond even blockchains, right? Like a lot of the focus of ZK has been within the blockchain context. But when you look at the amount of software that's in the world that needs to be verifiable, there's a huge opportunity out there to build systems in a better way. Right? Like think about whenever you are using services that require sensitive financial information, there's not only, an issue of data leakage where every single time you're putting in your data somewhere, you send it to every single website you interact with, right? So here in the US, we have social security numbers, right? And we use this as a form of authentication, right? So whenever I want to use a website in the US and I want to prove for a financial transaction or for an identity use case that I'm a US citizen, I put in my social security number. If that website gets hacked and they store my data in an insecure way, my social security number now gets hacked and my identity can be stolen. Clearly here, there's a way for me to prove that I'm a US citizen, right, without revealing what my social security number is. And this is where primitives like ZK are quite powerful. We see a lot of other applications outside of the blockchain context being remade using ZK, and it's something that we're really excited about. So I think kind of the moniker that we've adopted for this is that the goal of SP1 and the goal of Succinct is to really prove the world software. Let's not do things right in an insecure way. Let's do them in a secure way using powerful new primitives in cryptography to design better systems.
Yeah, so because I heard building a ZK circuit is very difficult, like what Starknet did. And so you facilitate all the process, right? You just connect to Succinct and you offer your service to this layer too.
So yeah, kind of the question they're asking is like, how do you actually use SP1 or use this versus custom circuits?
Mm-hmm.
Yeah, so basically, I'll kind of explain how SP1 works, and then I can talk a little bit about how the custom circuits used to work before, because I think it's an interesting contrast. So with SP1, what you can do is basically you write your normal program. Let's say, for example, you want to, let's say you want to prove like the 10th Fibonacci number. You'd write like a simple 5 or 10 line program that does the actual program of Fibonacci, right? So it's like whatever, like you get your 1 1 2 3, like 2 3 5, right? Like inside of a loop. And then before, what you'd have to do is you need to, so basically that's when you now have this like Rust program that's like written, it's like 10 lines of code. You essentially slap on this like entry point that we have that indicates that this is an SP1 program. Then you will use this SDK that we have called the SP1 SDK that'll read this program, see that there's an entry point specifying that it's an SP1 program, and it'll process the instructions corresponding to that program inside of the ZkEVM and output a valid execution proof for it. Basically, what's happening underneath the hood when that process occurs is that we take the Rust program, which is, I would show a diagram here normally whenever I'm demonstrating this, but you can just imagine something that's like pretty simple. And it takes that normal, language that you've coded in, and it compiles it into RISC-V, which is a reduced instruction set. Basically, instead of SP1, we run an emulator for RISC-V, right? So you can think about it as proving the execution of any RISC-V program. So you compile from Rust into RISC-V, and then we have essentially SP1 is a circuit that constrains the execution of any RISC-V program. So now you essentially have this flow where you have a Rust program, you compile into RISC-V, you give the RISC-V binary with some prefix in front of it indicating that it's an SP1 program, and you output the output of that RISC-V program as also like a special kind of output. So it's really this like two additions here, and now you have your proving the execution of any Rust program. Previously, if you want to do this, you essentially had to use a circuit system that was custom written for that specific application. So like, let's say, for example, you wanted to run this Fibonacci program, you couldn't just take, let's say someone else had implemented Fibonacci, right? So I have a library that implements Fibonacci. You can just take my library and run it inside of SP1. Now, inside of the context of custom circuits, if you're doing a more complex computation that's application specific, you would need to roll a lot of that library yourself. Let's say you want to modify my library slightly, you'd need to like essentially modify it inside of this custom circuit language, which would make it quite difficult to modify and maintain long term. So this is kind of where like the customization and extensibility of programs and custom circuits is quite difficult. Whereas in the regime of normal programs, I mean, people extend normal Rust programs all the time. So that's kind of where the delineation is. Now you can essentially take any library and prove it. Whereas before you kind of had to translate those libraries into the custom circuit language before you could prove them. Yeah.
Okay. Well, it's getting a bit technical right now. Can you just explain what is ZkEVM, maybe ZkEVM? What's different, for the community?
Yeah, definitely. So what is ZK? Like, what are zero knowledge proofs? Basically, zero knowledge proofs consist of, I'll give the academic definition, then I'll give, the actual practical definition after. So the academic definition of a zero knowledge proof is, it basically has like three main properties. It has soundness, completeness, and zero knowledge. So soundness basically means that it is difficult to convince someone that you have a valid proof without actually having the inputs to the valid proof. So what that means is, if I don't have the valid inputs that satisfy the statement that I want to prove, it's hard for me to convince you that I have that statement. Okay, that's soundness. Completeness basically means if I do have the valid inputs, I should be able to convince you with high probability that I have, a valid proof, right? So like given some valid inputs, I should be able to create a proof that you should always be able to verify is correct. And the zero knowledge property basically means that I can prove to you that a statement is true without revealing any of the inputs. So in the social security number example that we were talking about earlier, I can prove to you that I have a valid social security number without revealing what my social security number is. So those are kind of the three main properties of zero knowledge proofs. Now, the practical use case is you can prove statements without revealing all of the inputs, right? So, in the blockchain context for scalability, this isn't that important. But if you've ever heard of like Tornado Cash, this is where you essentially have a system that allows you to do private transactions, right? Or like you can privately transfer funds through this pool because you can essentially deposit into this pool. And then without revealing what account you deposited with, you can withdraw from the pool. So that's kind of the academic and then practical definition of how ZK is used. And so ZkEVMs are zero knowledge virtual machines. What that means is we can take any normal code and run it inside of the zero knowledge context. So before, zero knowledge cryptography was very academic. You had to translate your normal code into something that the ZK cryptography could understand. Now you can take any normal code and just run it directly. That's what the power of a ZkEVM is. So when I was talking about earlier about, running an Ethereum block, right? As you mentioned, teams like Starkware, who are pioneers in the space, had to spend a lot of effort, right, to convert the normal code into something that the Starkware approver could understand, right? Or they had to write essentially an implementation of, there's this team called Kakaro that used Cairo, which is Starkware's language, to write an implementation of a ZkEVM. Now we can just take the normal Rust code of an Ethereum client and run it inside of a ZkEVM. That's basically the difference. Yeah.
Okay.
Perfect. I think that that's essential because ZK is not an easy subject to discuss. Lots of people don't know quite well how does it work, what does it mean. So it's perfect. So we can continue to talk about Succinct. In August, correct me if I'm wrong, but I think it's in August, you published some benchmark about Succinct performance. Are they still relevant today? I mean, they are still up to date. And what does this benchmark mean for ZK? What Succinct have more than others as ZkEVM, for example?
Yeah, so kind of the two questions here are what do our recent benchmarks say about our performance, and what distinguishes SP1 from other ZkEVMs? Like why, there are many ZkEVMs that are out there. Like why is SP1 and Succinct so well positioned, right, to take advantage of building a great ZkEVM? So for benchmarks, I think when we were originally launching SP1, we wanted to show, I'll get a bit of a high level for why SP1 itself is so performant. So at a high level, the approach that we took with SP1 that was novel was that we really wanted to make it straightforward to accelerate operations that were commonly proven, right? So whenever you are proving, let's say, an Ethereum block, there are some operations that we noticed are quite common, right? So one of these is called catcheck. Catcheck is a hash. The catcheck hash is used to construct the state tree for Ethereum, right? So every single block, you recompute this. You have a Merkle-Patricia tree, and the hash function of that Merkle-Patricia tree is catcheck. If you decompose catcheck into its RISC-V equivalent, naively, it's a lot of instructions, right? There's like a bunch of bit operations, a bunch of addition, a bunch of multiplication. What if we know that catcheck happens often? Let's, instead of decomposing it into a bunch of RISC-V instructions, just constrain the Keccak itself. So we kind of use a custom circuit to constrain just Keccak. But then if we encounter things that aren't that common, like general purpose code, we process those as RISC-V. So within SP1, we call this a precompile centric architecture, right? So this idea of having a custom circuit for Keccak is what we call a precompile. And in SP1, we made it very easy to extend our ZkEVM with precompiles. So Keccak is one of them. We have a precompile for SHA. Within Ethereum transactions, you use a signature called ECDSA. So we have a precompile for ECDSA signature recovery. Tendermint uses a different signature algorithm. So we basically have a bunch of different precompiles for commonly used cryptographic operations that vastly speed up the performance of SP1. So when we originally launched, that was one of the big things that really, I think, distinguished our performance on real world workloads, right? So if you're executing Fibonacci, you don't see this, right? Because there's no common operations within Fibonacci that are really intensive. But in the blockchain context, and even in general within cryptography, there's a lot of operations that are quite common. And we noticed significant performance improvements by having acceleration for these specific functions. So when we originally launched, that's what made it more performant. And in recent months, we added support for GPU proving on SP1 that led to a 5 to 10x speed up over our existing CPU prover. And so we released benchmarks, I believe, back in August that detailed how our GPU performance made the performance in SP1 both more cost effective and just more effective generally. I think now what we're seeing is that, benchmarks tell somewhat of a story of performance, but what users really care about is the performance on their workload, right? So, you look at these benchmarks, but you want to do something slightly different. It's hard to extrapolate, right? Like, how do I know how this is going to perform on my workload if you're only benchmarking different workloads? Well, it turns out that because SP1 is now, ready to be used in production, we have support for proving with our prover network, people can actually assess the cost quite quickly with SP1 for their own workload. So I think, benchmarks were good when the project was in its earlier stages, but now that it's more mature, you can just benchmark on SP1 for your own workload. And that's kind of where we see the value of benchmarks being. I think one of the things that we did recently that we released after our benchmarks was this project called OP Succinct. I think we'll talk about this a bit later too, but that was basically proving the OP stack, which is a roll-up framework by Optimism inside of SP1, right? So we can prove the execution of an OP stack roll-up inside of SP1. And we put out some benchmarking numbers there. And that, for example, is a use case that is common and that people did want to benchmark in production, and that we enable people to benchmark quite easily for their own rollup. So there, right, like we have our own benchmarks, but people can actually go run that and see, how expensive would it be for us to run this for our own rollup? So I think, benchmarks are good, but they're point in time. I think even since those benchmarks, our performance has gone up by a significant amount, like at least 2 to 3x with more improvements to come in the future. So I think that benchmarks are a point in time measure, and they improve significantly over time, especially when these systems are underneath such rapid development. Yeah.
Okay. You talked about GPUs verifying. I heard there is some ASICs that are coming with ZK verification for Ethereum mostly. Are you interested in this technology for your Succinct verification? Yeah.
Yeah, I think one of the beautiful things about ZK is that it's self-verifiable, right? So if I give you a proof of some computation, that proof is self-verifiable, right? So you can just check that it actually proved the computation that you wanted to prove. So I think what this lends itself to is that any team that can make proving faster, either with better algorithms or, as you mentioned, better hardware, so FPGAs or ASICs, that just it just works, right? Like if you're able to generate a proof faster on an ASIC or an FPGA, it's immediately useful to people because it's cheaper and it can be faster as well. And so I think for us, it's tremendously exciting. And I think we'll see how the development goes. For us internally, I think that the iteration speed is probably faster on doing things on CPU versus GPU, and there are teams with a lot of hardware experience that are working on FPGAs and ASICs. So we'll see how the development of that goes. And it's something that we're pretty excited about because of this property that it doesn't matter where the computation gets done for ZK. It just matters how cheaply or how how quickly it gets done. Yeah.
Okay. And I'm in this space from 2 or 3 years, and we think ZK was very far away, and now it's getting more close. What's the limitation of ZK? Is it bandwidth? Is it cost? And how fast are we go today? How much is it to verify?
How fast is ZK moving?
Yeah, the development. Yeah.
I think that it's moving tremendously fast. And a lot of that is being pushed forward by ZkVMs, right? Like with ZkVMs, you are able to gauge very quickly for a variety of workloads how performant ZK is. Before, there was significant development overhead. If someone wanted to use ZK for their use case, it was hard. Now with ZkVMs, it's quite easy, right? Like you just take your code and put it in the ZkVM and generate a proof, right? Like that's very easy. So I think from that aspect, we're seeing that the development, right, of how easy it is for people to run ZK makes it also easier for teams to understand how to optimize their ZK systems, right? Like if we see that a specific kind of workload is taking off, we can spend time to optimize it, and our work compounds a lot over time because we have this general purpose system that can prevent any computation. So advancements, right, in one area or one specific workload often lend themselves to other workloads as well. Yeah, so I think that ZK is moving fast. And ZkVMs, like SP1, are a big part of that. Yeah.
Okay, great.
And so we are talking about SP1, so the prover. But I want to ask, what is Succint Network that we can see on the website and the documentation? What is basically Succint Network? How you would explain it to beginners?
We're going to have more information on this soon, but I'll give the brief intro. The Succinct Network is basically a place where the world's compute can come together to prove the world's software, right? So there's a lot of compute in the world, right? Like, with especially I think the rise of AI, we've seen how important compute is becoming and how much latent compute exists to do a lot of different computation. And a lot of this compute goes unused, right? And so I think there's actually a great deal of value unlocked by making it accessible for anyone to be able to use their compute in a meaningful way. And for people that want to generate proofs, a lot of them are quite cost sensitive, right? They're also sensitive to some other factors, right? Like people care about reliability, they care about censorship resistance, they care about latency. And I think aggregating more supply for proving and aggregating the demand for proving is going to lead to a lot of great outcomes for both people or both groups within this kind of a network, right? So you essentially get a lot of positive benefits from aggregating demand and supply for proofs. You get to take advantage of the latent compute in the world and also generate proofs more quickly in a censorship resistant way, right? Like a lot of the teams that we talk to, they are protocols themselves, right? So, they're decentralized protocols, and for them to have a dependency on a centralized service doesn't make sense long-term. They don't want just one party generating their proofs, right? They don't want to just be dependent on AWS for generating their proofs because, if they get big enough, and the US government or some other entity goes against that protocol, they don't want to be censored by AWS, so they prefer to be dependent on a protocol itself that is censorship resistant. So I think for that property, people care. I think for cost effectiveness, people care. And that's why we're really excited about the network.
That's awesome.
Yeah, so what are the next things that are coming to Succint Network? You say that there will be more announcement really soon. Can we have maybe some
Alphas?
details? What are the next thing for network?
I don't know how much alpha I can leak. So I will just say that keep an eye out. There is a lot of cool things that I've been working on for a while now that we're quite excited to share. So we'll have a lot more information on this, and it's something that's under a lot of active development.
Okay, perfect. We will look forward to it. So you are saying that Succint Network is basically a network of compute that are linked to Succint, basically.
Yeah, basically it's a network of compute that can initially generate proofs for SP1, right? So
Yeah.
right now, anyone can run their own SP1 prover, right? SP1 is like fully open source. It's like one of the big reasons why we made the project the way that it is in the first place. But it's not that cost effective for you to be running this yourself, right? Locally, there are people with quite cheap access to hardware and energy all around the world, and you should be able to take advantage of their compute for your applications. So I think that the Succinct network basically is a place where we can aggregate this supply of compute and connect it to the demand from applications to generate proofs, right? So ZK rollups care about generating proofs on a consistent, reliable schedule, and they care a lot about cost. Let's help get them better cost and also take advantage of the world's compute. That's basically the idea. So you have people that are running provers for SP1 and in the future beyond that on the network, and you connect them to applications that want to generate those proofs. Yeah.
Okay. I always wonder something, because I don't get if you have provers and proposers, or if the project need a proposer and you just have the prover, because the reaction is very important. I think it's a game theory, right?
What do you mean by proposers?
A proposer, the one who is asking the verification to the prover have to prove that transactions are okay. I think, if I remember well. Maybe I don't get it right, but there is two actors, right? Always. In ZK, I mean.
By the proposer, are you referring to like the proposer in a blockchain, or what do you mean by the proposer of the person that's requesting the proof? What do you mean by proposer? Maybe I'm not following.
I always thought there is like two actors, like there is one prover, one proposer, and the prover have to show there is a game theory between them. Maybe I didn't get it right. So what layer 2 need to get to Succinct? It just doesn't need something like a proposer or a sequencer. It just connect.
So you're asking in the context of like a layer 2 that wants to use SP1 to prove its validity, like how that setup works?
Yeah, exactly.
Yeah, so basically, I'm most familiar with the setup for the OP stack. I think some chains might have a bit of a different setup, but the idea with most rollups is that you should be able to fully derive the state of the rollup from what's posted to the L1. This is why rollups have the same security properties as the layer 1, right? It's like why you can use Ethereum as a native asset on a layer 2, because if the rollup stops for advanced rollup system or for rollups that are mature enough, you can permissionlessly withdraw, right? So there's a way to always be able to withdraw from the system. So right now, how that works is there are optimistic and ZK rollups. For optimistic rollups, essentially, the rollup is progressing, and the proposer posts a new state root for the rollup, at a fixed interval. After some time has passed, that state root gets finalized. How are we confident that there was no fraud on that state root? Like, how are we confident the right state root was posted? This is where the concept of fraud proofs comes in a challenge window, right? So on optimistic rollups, you need to wait, let's say, for 7 days for there to be no one saying, oh, this state root is invalid. Here's a proof as to why it's invalid. So on optimistic rollups, you give some time for people to say that the state is invalid and generate a fraud proof that that state was invalid. With ZK rollups, how it works is you essentially prove inside of a zero-knowledge circuit or a ZkEVM that the execution of the rollup was correct and that the data used, the transactions used to get the new state root actually were posted to the L1, right? So, the L2 posts data to the L1 at a fixed interval as well before the new state root is posted. And from that L1 data, you can derive the L2 transactions. And so within the ZK rollup, you essentially take that derived L2 transaction data, you execute it, get the new state root, and show this was a ZK proven state root, and you can immediately finalize the new state root. So rather than waiting for the challenge window, I post the state root and a proof, and the state root is now immediately proven in the best case. And so basically where the prover comes in here is that when the proposer is posting the state root, they'll also request for a proof to be generated of that state root being correct. The prover network will return the proof, and the proposer will post the state root and the proof together to the L1. That's basically how the prover plugs in. It's not really replacing the proposer. It's being used by the proposer to generate the proof. And this is why the proposer cares about having a censorship-resistant property to the prover network, because the proposer wants to keep the state of the rollup progressing, right? Like they want the state of the rollup to progress on the L1. So they need to be able to be sure that a proof can be generated at any time.
Okay. Let's say a L2 on OP Stack, the cost of a transaction is like 1 cent. Today, how much will be a cost if this rollup use Succinct? So ZK confirmation?
Yes, we have some benchmarks on this, right? Like that we posted with our OP Succinct blog post. And today, I mean, these numbers are moving significantly down as algorithmic improvements and hardware improvements come to SP1. But already we're seeing that for things like an ERC20 transfer, the cost is below 1/10 of a cent, right? It's on the order of magnitude of hundredths of a cent for an ERC20 transfer. Now, one thing that's interesting is, I think for a long time, people assessed the throughput of a rollup as transactions per second. But really what's a more accurate metric is the Ethereum gas per second, because while not a perfect metric, the Ethereum gas per second is supposed to measure the amount of compute costs, right, on the rollup, right? So like it obviously intermixes a lot of things such that the Ethereum gas is not one-to-one with the prover cost, right? Like for example, like there are certain things that are more expensive, like an S load, for example, is doing a read from the Ethereum state tree that requires a lot of catch-up hashing, right? So that might not match up one-to-one with the prover cost of it might not match up to the Ethereum gas cost. And so roughly though, as you scale the Ethereum gas for compute operations, you see that the prover cost increases. So like, let's say, for example, you have an operation that's 20K gas, like an ERC20 transfer, that might be less than 1/10 of a cent, right? But then if you have an operation that's 2 million gas, well, then that's going to be more expensive than that. So basically, there are a couple of metrics for looking at the cost of proving a rollup with ZK, but already today, for end users, I think this cost is already at a point where it's quite feasible, right? Like users
Wow.
on rollups that are doing a lot of financial transactions, like if you're doing like a Uniswap swap and you're moving like $100 of funds, paying less than 1/10 of a cent is de minimis to you, right?
Yeah.
If you're trading on a rollup, you're not going to care about paying 1/100th of a cent or 1/10 of a cent or less than 1/10 of a cent. But what you do care about is being able to take your money off that rollup in an hour rather than in 7 days.
Exactly.
So
Yeah.
I think it strikes a better trade-off for those rollups. Which is
Okay.
why
And
us.
oui, yes. Okay. And you announce you will be compatible with the OP stack, so we can create some ZkEVM in like 1 hour. I think that's what you said. Are you discussing with some OP stack layer 2? Is it on the table? Yeah.
Yeah, I think we're going to have an announcement about this soon, but there's a team that's getting ready to they're getting ready to deploy OP Succinct, which is quite cool. So I think it's something that we're really excited about. We've been chatting to a lot of teams with it. We have integrations with all of the top RAS providers, right? So Conduit, Caldera, Alchemy, Gelato, AltLayer all support OP Succinct out of the box. And yeah, we're really excited to talk to teams that are using OP Succinct. So if you're a team that's looking to convert your optimistic rollup that's on the OP stack into a ZK rollup, we have a very straightforward upgrade path for that. And that's something that we prioritized, making it seamless to convert your OP stack optimistic rollup into a fully validity proven ZK rollup.
Awesome. So good.
Perfect. So we are talking about others layer 2 on the OP stack, but can Optimism use Succinct today to maybe change his own proof system, or maybe when you have to be a stage 2 rollup, you need two different proof systems that can compete with each other in the case of a problem. Could Optimism use Succinct today, for example, to become a stage 2 rollup?
Yes, but I think that an OP stack rollup today could not, because the superchain needs to add support for it. Once that happens, yes. I think that it's a path that we're very excited about and that we've talked with the Optimism team about. I think that it doesn't make sense for every rollup, but it makes sense for a lot of rollups to be using ZK. And I think long term, it will make sense for most rollups to be proven with ZK. Yeah.
Okay. Great.
Okay. And that's a market you already have, right? The superchain, OP stack, and everything.
Yep.
Your competitor have some part, or it's your, because it's so big. The superchain is so big. It's a very big market right now.
Yeah, I think that it's something that we're really excited about. I think Optimism has done a great job with how they've architected their stack to be modular for the proof system that it accepts. There are engineers on their team who we've had a lot of fun working with over the past few months, and I think we're incredibly excited to see how OP Succinct could be connected into Optimism.
Okay.
And the superchain.
Yeah, of course. And I heard you're partner with Conduit, which is used as a AAS for most rollups, some rollups. What is it for? What is it about this partnership? How do you see it in the future?
Yeah, so with Conduit, we basically wanted to make it seamless for Conduit rollup deployments to move, for Conduit OP stack rollup deployments to move to using OP Succinct as seamlessly as possible. So they now have an integration where it's straightforward for anyone that is running an OP stack rollup on Conduit to use OP Succinct. So we announced that. It's been a lot of fun working with them. I think that they have a great grasp of where a lot of this is going. I think they're also quite excited about using ZK and fully validity proving these rollups.
Okay, awesome.
And so you have the partnership with Conduit. And of course, there is also Celestia. You talked earlier about the blob stream. So basically, can we just explain briefly what the blob stream is in the big lines, and what is the goal for Succinct to partner with Celestia in this specific domain, and what is the ultimate goal for Succinct to partner with Celestia on this topic?
Yeah, I think it's a great question. And I think it links into the OP Succinct things that we were talking about, right? We had an announcement with Conduit and Celestia earlier this month. So basically, I'll explain both, right? So what is Blobstream, and then how does it connect to OP Succinct? Blobstream is basically taking, what is Celestia? Celestia is a data availability layer, right? Where you can post, for example, the data necessary, the transaction data necessary to prove the state of your rollup. So if you're an optimistic rollup, the data that is used for fraud proofs needs to be accessible for a certain period of time in order for people to generate fraud proofs. For ZK rollups, that data is necessary to generate the proof for the rollup. Right? Like I need to have the transaction data to generate a proof for the rollup. In the initial design of a lot of these rollups, they were just using Ethereum for DA, right? So Ethereum had an upgrade, EIP 4844, that went in last year that made blobs, that made it cheaper to post the data, transaction data for rollups. So Blobstream essentially is Celestia's bridge to Ethereum, where rollups that settle to Ethereum but use Celestia for DA can now prove their security using Blobstream, right? They need a secure way to access data on Celestia within the context of Ethereum mainnet, right? And so what Blobstream does is it validates the signatures of Celestia's validator set over the data that has been posted to Celestia, right? So Celestia validators are always signing off on the data being posted to Celestia, and we verify that the signatures are correct instead of Blobstream. So how does this connect to OP Succinct? Well, with OP Succinct and the OP stack, they have support for alternative DA providers, right? So there are a bunch of alternative DA providers, right? Celestia being one of them. And basically, we wanted to also have out-of-the-box support for rollups that have Ethereum settlement, but Celestia DA. The way that those rollups prove that their transaction data has been derived correctly is by using Blobstream within the context of OP Succinct. So in the default OP Succinct mode, you're validating the blobs are correct. Inside of Celestia OP Succinct mode, you are validating that the data posted with Blobstream is correct, and then using the data posted with Blobstream to derive the transaction data that you pass to the executor, which gives you the new state root. So I think we worked very closely with engineers on the Celestia team, one of them particularly Diego, who worked on that integration. And now we have support for any rollup that is using Celestia DA with OP Succinct. So yeah, it's something we're really excited about, and that's basically how it works.
That's great.
Okay, awesome. And I always thought you are not gonna launch a token, but you talk about Succint Network, so you need to be censorship resistant. Is a token is something on the table, or maybe you will do an AVS? I don't know, or nothing at all.
I think that it's something that we want to see what the adoption of the Succinct network is. I think that it's like a very important problem for people today, even a lot of teams that we work with. So we're excited to see how the Succinct network develops. And I think that, I think there's a lot of work to go.
Okay. Awesome.
That's great. So What is the business model of Succinct at the moment? I mean, you're partnering with other projects and everything, but what is the revenue stream of Succinct right now? What can you disclose about it?
Yeah, definitely. So I think today it's proving, right? Like a lot of teams need reliable proving for real applications. As I mentioned, right, Celestia and Avail and other partners fall underneath this category where they have real applications that are deployed today in production, and they need to know that the proofs will be delivered in a reliable fashion. We provide reliable proving for those partners. I think long term, that's going to be provided through the Succint network. And I think that, we're going to continue to be an active prover on the Succint network even after it launches. And I think it's long-term an area where, we're quite excited about. Yeah, I think like proving is our revenue stream.
Okay. And looking into the future, you know that recently Vitalik published lots of articles about the Ethereum roadmap, especially about everything related to ZK. Even Justin Drake talked a lot about the Beam chain to Snarkified. I use his term, everything about Ethereum. In what extent can Succinct be useful in the Ethereum roadmap, and in the other way, how the snarkification and the ZK on Ethereum can help Succinct be better, cheaper, faster, everything that could help?
Yeah, I think that the roadmap is something that we're quite excited about, right? Like this essentially is the adoption of ZK at the base layer for, all of these rollups. Like Ethereum is, I think, one of, if not like the best projects in crypto, right? So I think to us, it seems very clear that the adoption of ZK is like close to the end game for what Ethereum looks like, right? Like you essentially have this layer where, you no longer have to run a full node that is re-executing all of the transactions. Instead, you just accept a proof, right? And so this means that, right now, if you want to run an Ethereum node, I'm not sure if either of you have, but, I've set up a couple in my day, and I think that you're running on these machines, right, that are, somewhat large, especially if you want to run a full node that's, actually executing all the transactions. And the ability for anyone and everyone to run a node, I think, is a critical part of, what Ethereum cares about when it comes to decentralization. And I think that ZK is a very cool part of that roadmap. So I think it's something we're really excited about. And, Justin Drake mentioned how, they're thinking about even enshrining, right, ZkEVMs at the fundamental layer as one of the provers, if not like the prover for Beam chain. So I think that it's something that we're tremendously excited about, seeing, SP1 adopted, right, at that kind of fundamental layer. And we're keeping a very close eye on it.
Okay. Well, that's great. We are approaching the end of this hour with you. That was great. And I have the final question, maybe my preferred one. Today, what could be the best advice you can give to a young investor in crypto in general, not a ticker, not a token to shield, but a general advice that could be useful for anyone in crypto?
Yeah, I think it's a good question. I mean, I think for me, what I've found to be the most interesting is just thinking a lot long term about what the end state of crypto should be like, right? How are these systems going to look in 5 years? And then focusing on the technologies that are quite important to make that happen. I think there's a lot of noise in crypto, but there's certain technologies that it's very clear how powerful they are. And the advancement of that tech is sort of like an unrelenting force. So I think for me, it's like identifying what tech is going to be clearly important in 5 years and focusing a lot of effort into understanding and building on top of that. Yeah,
that's good.
ZK is a big example of that. And there's a lot of other tech too within crypto that falls in that category.
Okay.
Well, do you have any topic that we didn't mention that you want to bring to people, Ratan, before the end?
I think that we covered a lot of ground, honestly. I mean, I think we went everywhere from talking about, about SP1 to about OP Succinct, about like Blobstream. I think that, what else? I think there's a lot of cool applications within ZK that are getting adopted that are not just for like scalability. Like some of them that are quite cool are like, we hosted this residency 2 months ago or a month ago or so, where a bunch of teams came in to like work on different projects on top of SP1. And there was like a particular project called ZK Passport. There's another one called like Open Passport. They were basically doing the same thing, which is, you can prove that you have a passport corresponding to a specific country. I think, these kinds of projects where you are taking existing systems and applying ZK to them are very powerful, because you essentially are able to bootstrap anonymous identity without needing to do distribution, right? Like on day one, most people, right, that are kind of within crypto, especially people that like went to DevCon, have passports, right? Like they fundamentally need passports to go to this country. And with ZK Passport, you now have a primitive that people can use to build cool applications. So like, for example, one thing that I was talking with, I can't remember if this was the WorldCoin team or someone else, but basically people were using either WorldCoin or ZK Passport to run shadow elections in countries that don't have free and fair elections. So, for example, like Venezuela and Iran don't have free and fair elections, right? Like there was a whole set of protests, right, against Maduro in Venezuela over the way that he handled the last election. And in Iran, it's also a big issue too, where like the government doesn't let people vote in elections. And so using, I believe it was ZK Passport, people proved that they had, an Iranian or a Venezuelan passport, and then they voted in the election as if it was a normal election without revealing their identity. But external people knew that the only people that could vote were people with an Iranian passport or with a Venezuelan passport. That's a really cool example of, this is existing tech that's already distributed, right? Passports have, these chips inside of them, which are signed by the country indicating that this is a passport for that specific country. You combine that with zero-knowledge cryptography, and you get this emergent behavior of actually building better, more secure systems that let you fight against, tyranny. I think it's something that's really cool and something that I'm really excited about that isn't really tied to, the scalability stuff or the ZK stuff. And it shows a lot of what the power of ZK being applied outside of the blockchain context is.
Yeah. I don't remember the country, but I heard there is one country in South America that use ZK from ZkSync, if I remember well, for all the papers, right? I don't remember the name. It's Quasar or Quar. You know that project?
I don't think so, but I have heard of something similar. Like I know Raramo got adopted, I believe, in a country in the Balkans or somewhere essentially.
Oh, really?
Yeah, okay. I believe it was Georgia, but I'm not sure, where they essentially are doing their voting using Raramo, which is like a ZK voting application.
Okay, that's awesome. Awesome use case.
Well, Ratan, it has been a great hour with you. Thank you so much for being with us today. This interview was very great, and I hope people will understand ZK better and the use case that are going for Succinct and everything that will launch pretty soon. We will look forward to it, and thank you for your time. It was very good.
Yeah, this was a lot of fun. Thank you. Thank you for having me on. This is great.
Thanks.
Well, Ratan, take care. Thanks for the show, and don't worry. I remember you to subscribe to Decrypted channel. Bye, guys.
Bye.
Thank you.